Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zafar bin Muhammad Zubaidi. Today, I and my friend we explain about a group project assignment platform circuit analysis. The title project of this project is application of failure analysis in RLC circuit. The member's name for this project is Muhammad Haris Akmal bin Muhammad Hairani, Muhammad Amir Amirul bin Alias, and me, Muhammad Zafar bin Muhammad Zubaidi. We are from group 13 and we are from section 5. For the introduction for this project is the first Fourier transform, commonly abbreviated as FFT, is a fast algorithm for computing the discrete Fourier transform of a sequence. The purpose of this project is to investigate some of the mathematics behind the FFT, as well as the closely related discrete sine and cosine transform. We will produce a small library of MATLAB code which implement the algorithm discussed. Then I will pass to my friend for the calculation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris Akmal Muhammad Hairani, and I will explain about the calculation. Here, this is our circuit, which is we use a mesh circuit with two resistance 10 ohm and 100 ohm, and one capacitor 5 microfarad, and one inductor 3.5 Henry. First, we need to find we need to change the transform the circuit to the S domain circuit, which is into the J n pi L for our inductor, which is 3.5 n pi. For our capacitor will be negative J 200,000 over n pi. And then our Vs, which is 1 over 2 plus 2 over 5 sum of 1 over n sine n pi t. And then we will insert n number, which is 1, 3 and 5. For n equal to 1, Vs will be 2 over n pi with angle negative 90 degree, and result we obtain is 0.6366 angle negative 90 degree. For n equal to 3, we get 0.2122 angle negative 90 degree, and for n equal to 5, we get 0.1273 angle negative 90 degree. And then our VST is 1 over 2 plus 0.6366 cos pi t minus 90 degree plus 0.22 cos pi t minus 90 degree plus 0.1273 cos pi t minus 90 degree. Next, we will simplify the circuit. Before that, we need to find the ZT, which is our total impedance for the circuit. And our total impedance, after we calculate the parallel and use voltage divider equation formula, we will get ZT equal to R plus bracket RSL over SC over R plus SL plus 1 over SC. And then to find VO, we use the formula Z over ZT times by Vs. And after simplify and elimination method, we get VO RL over R squared C plus RSLC plus 2RL times by Vs. And then for Vc, we get RSC plus S squared LC plus RSL over S squared L plus 1 times by Vs. And for the VR, it is equal to VO, which is RL over R squared C plus J and T RLC plus 2RL times by Vs. After that, we will find the value VO for when n is equal to 1. And after we calculate it, we get 0.318 angle negative 90 degree for n equal to 3. we will substitute the n value with 3 in the calculation, and we get 0.11061 angle negative 90 degree. And for VO5 n equal to 5, we get 63.7 milli angle 180 degree. For every VO, when n equal to 1, n equal to 3, n equal to 5, we also need to calculate the current for I1 and I2. I1 is the branch which is only have R equal to 100 ohm, and I2 which the branch that have SL parallel to 1 over SC. Next, we need to find the VC, V capacitor, using the formula that we calculated earlier, which is Jn pi RC plus Jn pi squared LC plus Jn pi RL over Jn pi squared L plus 1. For VC, when n equal to 1, we will get 2.03 angle negative 88.3 degree. And for the IS, by using formula VC over R1, we will get 0.203 angle negative 88.3 degree. For n equal to 3, we get 0.234 angle negative 89.82 degree. And for the IS, we get 23.4 milli angle negative 89.82 degree. And the last one, VC5, 80.9 milli angle negative 89.9 degree. And IS5, 8.09 milli angle negative 89.0 degree. After we get all the value, we will rearrange all the value like the VST earlier, and we'll get VOT, IOT, IRT, and IST. And then, after we got all the value, we will find the power for every component. First one, power at resistor. We get 25 milliwatt. Power at capacitor, 234.1 milliwatt. And power at inductor, 25 milliwatt. That's all. And I will pass to my friend to explain the simulation.
Okay, Assalamualaikum. My name is Muhammad Amir Amirul bin Alias. Today I will present about simulation of our project. So we are using software OrCAD Capture to draw the circuit for our simulation and PSpice software to get the result. For our diagram, we have two resistors, R1 10 ohm, R2 100 ohm, one capacitor 3.5 farad, and one inductor 5 microhenry. So the we need to get observe the current and voltage for each branch. To get the value of the current and voltage, we just simply put the voltmeter here. For example, R1, then run the simulation. So we will get drop at R1 is here. The graph is it show that after a few seconds the voltage will peak to 12 volt. Okay, so we will show that for all voltage drop at all branch. Okay, this is the comparison for all voltage drop at R1, R2, C1 and C2. Show that the value drop at R1 only 12 volt, and at capacitance 1, inductor 1 and resistor 2 the value is almost zero. The value of voltage is very low. Then I will show you the result for current. Okay, how to collect the current? Just simply put emitter here. I will show for all branch together. Just give the example for the first. Just run and okay, this is the comparison for current flow at all branch. The green color graph is for R1, the yellow color graph for R2, the purple color graph is for L1, and the red color graph is for C1. The current drop at R2 is almost zero. Current drop at R1 equal to almost 3.2 1.5 ampere, and current drop for C1 and L1 is simultaneous, is drop and high. Okay, last is we need to find the power at one of the branch using fast Fourier transform. So I choose R1 to check the power. Okay, so the value of fast Fourier transform we get like this. The power is dropped from 14 volt to 0 volt. Okay, that's all from the simulation. Okay, that's all for our group.